For decades, science fiction writers and futurists have imagined humanity's encounter with extraterrestrial intelligence in grand dramatic terms. Benevolent visitors offering wisdom from the stars, or powerful invaders descending on a trembling Earth. But according to a new scientific hypothesis by David Kipping, the first confirmed detection of an alien technological civilization is unlikely to resemble those familiar stories. Instead, it may come from an atypical, unusually loud signal, a techno-signature far stronger than the background of space, and possibly from a civilization in crisis or even collapse. Kipping, director of the Cool Worlds Lab at Columbia University, argues that history teaches us a fundamental lesson about discovery. The first members of any class of objects that we detect are rarely typical of the whole. In astronomy, this has been repeatedly confirmed. For instance, the first exoplanets humans found in the early 1990s were not Earth-like planets orbiting sun-like stars. They were planets around pulsars, the incredibly dense and exotic remnants of exploding stars. These early discoveries were not representative of the broader population. They were simply easier for our instruments to detect because their effects on a pulsar signal were dramatic and unmistakable. Kipping extends this observation to the search for extraterrestrial technological civilizations. This idea, which he calls the Escatian hypothesis, suggests that we should expect the first techno-signature we detect to come not from a stable, mature civilization, but from one that stands out because of extreme activity or unusual energy emission. That could include dramatic bursts of radiation, vast engineering projects in their final stages, or other anomalous phenomena that produce strong observational signatures. The term Escatian derives from eschatology, a field of thought concerned with ultimate endings and final destinies. In this context, it reflects the possibility that the first technological civilizations we notice aren't thriving, steady societies, but ones experiencing a transitional or terminal phase, perhaps dramatically using massive amounts of energy in ways that make them temporarily detectable from across space. Why would this be the case? According to Kipping's models, even if a civilization is only in an exceptionally loud state for a tiny fraction of its lifespan, that loud phase may still dominate detection statistics because quieter, stable civilizations don't emit easily observed signals. In other words, the brightest, most energetic signals are easiest for us to notice with current instruments, and those are the ones we're most likely to interpret as contact. This scenario has profound implications not just for what we might detect, but how we should search. Kipping emphasizes the importance of continuous, broad, and agnostic monitoring of the sky, rather than targeting narrowly defined techno-signatures like deliberate radio transmissions. Instead, powerful surveys that look for anomalous transients, sudden changes in brightness, unexplained bursts of energy, or unusual spectral features may be humanity's best chance to catch the first sign of extraterrestrial technology. Some have even speculated that historically mysterious signals, such as the famous 1977 WOW signal, could hypothetically fit this pattern, representing not a civilization at its peak, but one making a loud, perhaps desperate, attempt to communicate. While this remains speculative, it underscores the idea that our first contact might be far stranger and more chaotic than we imagine. Ultimately, the Escatian hypothesis invites scientists and the public alike to rethink the narrative of first contact. Rather than assuming contact will be peaceful, orderly, or representative, we should be ready for the unexpected. A blazing signal from a distant world that reveals not a thriving cosmic neighbor, but an extraordinary and perhaps fleeting phenomenon.